Objective number 4. Use a graph to locate local maxima and local minima. Definition of the local maximum at C is that if you plug in any number C into the function, the output is f of C. That output is always bigger than the other output. Then you say f of C is the local maximum value of f. If you plug in the C into the function, you get the output f of C. That f of C is always lower than the other output. You say f of C is the local minimum value of the f. When you're talking about the value, the local minimum value or the local maximum value, they are talking about the output. F of C means the output. The idea is very simple. For example, I have the graph, for example, something like this. If you notice that we have those points, you imagine like there are mountains next to another mountains. If you are at the pink point, you are on the top of the mountain, and those points called the local max. So all of the pink points are the local max. And the green point, if you are here at the green point, you are at the lowest location. So those points like in the valley. So those points called the local mean. The local max you got when you go from left to right, and when you go up and then you change it to going down, you get the local max. So increasing and then decreasing, increasing and then decreasing, you got the local max. And we got the local mean when from decreasing you go increasing, you go down and then you change it to up. The local max and the local mean from the other book, they said they are the turning points when it changed from increasing to decreasing or from decreasing to increasing. The idea of local max and local mean very simple. You just think that you are on the top of the mountain or in the valley. The local max we can have in one graph can have more than one, and the local mean also can be more than one. Example number 4, they given us a graph and they asking us the first one, f. Does f have a local maximum? So look at the picture and we can see that this is like on the top of the mountain. So 1, 2 will be the local max, and the local mean will be, that will be for part B, it will be the green point. Now we need to answer the question, what value of x, if any, does f has a local maximum? So we look at the pink point, we will say the x value, the pink point is 1, 2, so the x value is 1. List the local maximum value. You go back to this part I just highlight in the definition. Local maximum value, they're talking about the output, and the output is the y part. So we said 2. So we got the point 1, 2. 1 is for the x and 2 is for the y, and also it is for the local maximum value. We can answer like this. F has a local max at x equal to 1, and list the local maximum value. So the value is 2, or you can say f of 1 equal to. So that is the correct way to answer this question. For part B, we have two answers because we have two real points for the local minimum. So we would say f has a local minimum at x equal -1, which is this point, and this point, and x equal 3. And now we answer the value. So f of -1 equal 1, and f of 3 equals 0, because this point is 3, 0. Part C, find the intervals on which f is increasing and f is decreasing. So we remember that we go from left to right. So this is the left and this is the right. So we're going to start from the orange point right here. When we go like this, it's going down, so it's decreasing. So the answer for decreasing is from -infinity to -1. And also we have this orange point also is also decreasing when you go from left to right. So from 1 to 3. And look at the purple point. The purple curve is increasing and also increasing if we go from left to right. So increasing, the interval will be from -1 to 1 and from 3 to infinity.